Okay, so today we're going to be talking about radical expressions and functions. Um, you've probably heard of radicals before, even if you haven't heard the word radical in this sense. You'll recognize it. Like, say for example, a square root is a radical. That's just another. Well, it's not another word. Any kind of root. So if you have a square root, a cube root, fourth root, fifth root, any kind of root is a type of radical. So, of course, this we know is equal to 6, but a radical expression is going to involve something a little bit more complicated, say like x plus 3 is the radicand. This is what we call a radical expression. So this is the type of thing that we're going to be dealing with in this section, but I also want to show you well, let's just go straight into it. Let's go into an important definition. So, okay, so the definition of x to the power of 1 over n, x to the power of 1 over n, let's put that in a new line so it's a little more clear. X to the power of 1 over n, let's move a little bit to the left, is equal to the nth root of x. So x to the power of 1 over n is equal to the nth root of x. You probably remember hearing me mention that in the last video. It's a very important concept. But to generalize it a little bit more, let's write it like, what if this isn't a 1 up here? So let's say that we have x to the power of m over n. So x to the power of m over n. Well, this is going to be equal to the nth root of x to the power of m. So the m goes here and the n goes here. It's very important that you don't mix those up, because if you have m here, then you change the problem. You change the value of the inside. But also, this m can go under the radicand, or it can go outside of the radicand. So let's not radicand, radical, excuse me. It can go under the radical or outside the radical. So let's rewrite this as square root, or sorry, not square root, the nth root of x to the power of m. So that means this can go here or it can go here, and depending on what you're doing, one might be more useful than the other. You just want to use whichever one is more appropriate for your situation. If you're evaluating something, like if you have 16 to the power of 3/4, it's easier to put the 3 on the outside than it is on the inside. You could put it on the inside and it'll still work the same, but then it's easier to take the fourth root of 16 than the fourth root of whatever 16 to the third is. But there's also cases where, when you're simplifying an expression, you'll want to have the m on the inside of the radical. So let's go on to an example of changing radical expressions to expressions with rational exponents. Okay, let's scroll down to expressions with rational exponents. So we're going to be using these rules that we just mentioned. So let's say, for a very easy example, we have the mth, third root, not mth, I'm thinking of something else, of x to the power of 2. So we have third root of x to the power of 2. Well, this is just almost exactly like this. Actually, it is exactly like this. It's just that we have a 2 instead of an m and a 3 instead of an n. So we can rewrite this as x to the power of 2 over 3. Okay, so again, I want to reemphasize that you want to make sure you don't mix this up. The denominator is going to be the root, and the power, the numerator is going to be the power. So this is an example of something that's been changed to, was a radical expression and has been switched to a radical exponent. Let's go on to a slightly more complicated one. This is the type of thing that you might see in homework questions. So you say we have the fifth root of 32x to the power of 10. So fifth root of 32x to the power of 10. Now, first let's go ahead and use all of the individual power rules. So we'll see that this is equal to 32x to the power of 10 all to the power of 1/5. Okay, so all I did was I rewrote this putting the 1/5 on the outside. And now this 1/5 is going to distribute to the 32 and the x to the 10th. So this is going to equal 32 to the power of 1/5 times x to the 10th to the power of 1/5. Oops. Typo. Okay, so 32 to the power of 1/5 times x to the 10th to the power of 1/5. Okay, so 32 to the power of 1/5 is going to be 2. And the reason why that is because if you take 2 to the power of 5, you'll get 32 back. So that means that this, let's go on to a new line. So this is equal to 2. And then what do you do with this here? Well, you have this x to the power of 10 all to the power of 1/5. Well, then you can multiply these two together. 10 times 1 over 5 is going to give you 10/5 or just 2. So x to the power of 2. So this weird mess becomes something pretty simple, x to the power of 2. So that is, this is the type of thing that you'll see and the type of work that you'll be doing. But let's go on to another section, changing the other way around, changing expressions with rational exponents to radical expressions. So let's go straight into an example. Oh, you know what? Before I even do that, I want to show you something else. I just thought of this. There's a shortcut for doing this. You can do this, and this is good, and if you want to go ahead and show these individual steps, that's fine. But also note that you can say that what's the fifth root of 32? Well, it's going to be 2. And what's the fifth root of x to the 10th? Well, it's going to be x squared. So if you can see that, if you can understand it, you can go ahead and just distribute this fifth root to the individual parts and get 2x squared. Now, the reason I want to show you this is because I want to show you the powers, the way it works in action. But let's go ahead and do it the other way. Let's go ahead and show you another way to do it. It's actually it's really not another way. All it is just another way of thinking about it. But it's ultimately the same thing. Let's say we have 32x to the power of 10th. Okay, fifth root of 32x power 10th. Well, and of course that's the same thing. So then that's going to be the same thing as 30, the fifth root of 32 times the fifth root of x to the power of 10. Okay, so what is the fifth root of 32? Well, that's going to be 2. And what is the fifth root of x to the power of 10? Well, I could show you the individual rules. I mean, basically I did do it over here, but you have x to the power of 10 times the power, x to the power of 10 all to the power of 1/5. So that means that this is going to be equal to x squared. But to to explain it again, what I have is the fifth root of x to the 10th, and that means you're just going to divide 10 by 5 to get x squared. And this is another way of thinking about it, and it might be easier, but if you find yourself getting lost in this, then go ahead and default back to this if you have trouble. If you find that when you do the homework, if you're getting answers not quite right, then try to find out where the answers are wrong, and you might want to go ahead and do this. And if this helps you, then if it's easier, sometimes I'd like to do things the long way just to make sure that I'm not messing it up somewhere. It's always easy to mess this stuff up. Okay, so now we go on to the next section, changing expressions with rational exponents to radical expressions. Okay, so let's scroll down a little bit and scroll a little bit to the right. Okay, so let's just jump straight into an example. Say we have Say we have xy to the power of 3/2. Okay, so this 3/2. Okay, that gave me a little bit more room. So this 3/2, we can rewrite this with the 2 as a radical. So this is equal to the square root of xy to the power of 3. Okay, so this 2 became the root. Remember that the denominator will become the root, the numerator will become the power. That's always important to to remember. Don't mix them up because you'll get something wrong. And now the second root is the same thing as the square root. That's just what the square root is. So we can just leave off this 2, and it means the same thing. So I'm going to go ahead and delete it. So that we just have the square root of xy cubed. Just be aware that if you don't have anything here, that means it's the second one. So if you're wondering why a 2 disappears because it was a denominator, check to see if you're taking the square root of something, because that's what happened to the 2 then. So now I want to go ahead and simplify this a little bit further. So in this case, I have the 3 under the radical, because if you have the 3 outside the radical, then I won't be able to simplify. But this 3 can distribute to the x, and it can distribute to the y, to give us the square root of x cubed y cubed. Okay, so the 3 distributed, and this is going to be our final answer for this particular example. So let's go on to another example. Something that's pretty similar, except this one actually involves a number. It's the 2 root to the power of 4/5. Okay, so let's scroll down a little bit. The 2x to the power of 4/5. So that's going to be equal to the 5th root of 2x to the power of 4. So the 5 became the root, 2x on the inside, and then the 4 just on the inside of it. Remember to put the parentheses here. So then the 4 will distribute to the 2, and it'll distribute to the x, and you will get the 5th root of, and 2 to the power of 4 is going to be 16, and then x to the 4. So you have 2 went to the 4 to make 16, went to the x to make x to the power of 4, and that means that this is going to be our final answer. That is as far as it goes. But let's go ahead and do one more example. This is more of the type of thing that you'll see in homework or like a test or a quiz. It's more the type of thing that you'll just be seeing, like more questions that you'll be asked. So let's say we have the fourth root of 81 times a to the power of 12 times b to the power of 20. So the fourth root of 81 times a, sorry, I need to put in, I had a typo. Okay, so fourth root of 81 times a to the power of 12, b to the power of 20. And what we want to do is we want to simplify this. So, example, simplify. Now, remember the rule that I said a minute ago? Let's go ahead and start with that, but then I want to go ahead and do it the long way. So what is going to be the fourth root of 81? Well, the square root of 81 is going to be 9, and the square root of 9 is going to be 3. So that means 3 times 3 times 3 times 3 is going to give you 81 back. So that means the fourth root of 81 is 3. Now, what is the fourth root of a to the power of 12? Well, 4 divides 12, so that means we can say we can say 12 divided by 4 is going to give you 3, so it's a to the power of 3. And again, if that, if you get lost in that or anything, then feel free to go ahead and write out the individual rules, which is what we're going to do after this. So then b to the power of 20, well, you can divide that 20 by 4 and you'll get 5 back. So that means that 3a cubed times b to the power of 5 is going to be our final answer. But again, let's go ahead and do it using the individual power rules, just so that we can see more clearly what we're doing, and then you'll see that these work out the same way. So this is equal to 81 times a to the power of 12 times b, 12 times b to the power of 20, all to the power of 1/4. Now this 1/4 is going to distribute to the 81, to the a to the 12, and to the b to the 20. So this is equal to 81 to the power of 1/4 and times a to the power of 12 to the power of 1/4. Oops. It's easy to mix that part up. So a to the power of 12 to the power of 1/4 times b to the power of 20 to the power of 1/4. I did it again. Same problem as before. Let's go ahead and put this on a new line too. I think I can just scroll to the right. Okay, so we've distributed the 1/4 to every individual part. Well, what's the fourth root of 81? Well, the fourth root of 81, like I said before, is just going to be 3. And the, let's bring that up a little bit closer. It's just going to be 3. And what's a to the 12 to the power of 1/4? We multiply these two together. So what's 12 times 1/4? It's going to be cubed. So it's going to be a cubed. And then what's b to the 20 to the power of 1/4? We multiply these together. What's 20 divided by 4? It's going to be 5. So it's b to the power of 5. And so this is going to be our final answer. And notice it's the same thing that we have up here. So that means that we did our individual rules correctly. Okay, I believe that is the final example I have. But I will say this one more thing though. This last example, this simplified, this is the type of thing that you're going to be using these rules most often for. Because, I mean, look at these, compare these two. I mean, this is a big complicated expression. This is a lot simpler. So that's the one on the right is going to be a lot easier to work with. So that's why we want to do this and why it's going to become very useful for later sections. So that concludes this video for now. I will see you for section 8.3, I think. I'm not sure what the next section we're doing is. I'm going to take a wild guess and say it's 8.3. It could be 8.4. Okay, so see you later.